Welcome to part 2 of Competency 3 quiz. In this video, we will continue to work with operations and number theories. Number 7, what is the value of the expression 3 to the negative 1 power divided by 1/3? Well, let's put that in the calculator and see what happens. Okay, so that's 3 carried up, negative 1, arrow all the way over. Okay, now let's divide and put in a fraction, 1 over 3. Okay, make sure we entered it correctly and enter, and the value is 1. And if you kind of saw real quick and you knew the rules of the different theories, the first one is 1 over 3, and then this would be times, okay, because if you remember the rules, this negative 3 to the negative 1 power, it comes down to the denominator, okay? That's equivalency. But now, when we use the rules of dividing by a fraction, you leave the first fraction, multiply, and then use the reciprocal of the second fraction, which gives us 3 over 3, which equals 1. But our calculator will suffice. Okay, let's look at number 8. Okay. Use the theorem below to answer the question that follows. If the sum of a number's digits is divided by 3, the number is divisible by 3. Which of the following ways of expressing a 3-digit number, now that's important, okay, we're talking about a 3-digit number n, best demonstrates why this theorem is true. Okay, now look at A, B, C, and D. We have 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. So it looks like they've taken the digit and now you have each term added together. Now let's think about that. Multiples of 3. Well, you have 3 times 1 or 3 times 3, 2 times 3, okay? So if we use each of these, and we have A and B and C, and we're not saying that A, B, or C is actually divisible by 3. So what would happen here? We would end up with, okay, look at A and B. We would have 10 and then 10A plus the B and then plus C. Okay, I'm sorry, but that makes no sense whatsoever. That looks like to me that we're talking about dividing by 2, or we could have said 2 and 5. But if you look at it carefully, we've got 2 times 5. I don't see where 3 is involved, okay? So mark that out. Okay, now let's look at B. That's kind of the same thing going on. I see 2, I see 5. Because of the 10, I don't see where anything is divisible by 3. Okay, so I'll mark that out. I know it's a simplistic way to look at it, but if you start playing with the numbers, you'll see. Now, C is different. I see 99 plus 1. I see an attempt to give me something divisible by 3. So I'm going to kind of underline that because I think I may go with it. But let's look at D. Well, 300 divided by 200, that's just 100. And then 30 minus 20, that's 10. And then this is just 1. Well, doesn't that look like the same conundrum we had with A and B? It is. So I marked that out. So let's look at C. Let's give it a go and see what happens, okay? Now, before we do that, I'm going to look at the theorem, and I'm going to do a little side note here. They said the sum of the numbers digits is divisible by 3. Okay. Now, the sum of the numbers digits. So if we look at it like this, now let's not talk about the 3-digit number. Let's just talk about a 2-digit number to kind of simplify this. Let's look at it this way. Let's say that I had 39. Okay, 3 is divisible by 9. 3 is divisible by 3, and 9 is divisible by 3. Okay, I kind of separated, put them apart so you could think of them as digits. Now, we know that 3 plus 9, okay, and I'm going to say divide by 3, that is equal to 12. So if we add the 3 and the 9, that's 12. We divide that by 3. We actually get something clean, which is 4. So if we look at it in the 2-digit situation, it looks solid. Okay, so now let's look at the theory of this. Well, let's look at C. We're going to try to take a look. And unfortunately, the only way your calculator is going to help you is if you actually use values. So I have A times 99. Okay, I buy that. Plus A plus 9B plus B and then plus C. See how I distributed? Okay, we've got it distributed. So now there's some things we can put together. Here and here. Well, we want to divide by 3. So let's show that it's divisible by 3. Let's take out a 3. Okay, for this first one here, I take out 3. Well, that would be 33A. Okay, and then I'm going to look at the 9B. Well, that would be plus 3B. Well, that would tell me that this entire situation is actually divisible by 3. Okay, now I'm not saying that A and B could be added together, but I need to show you a situation, regardless of what A and B are, I can divide by 3. Now let's take, here, I'll highlight this, A, B, and C. Okay, and we have A plus B plus C. Okay, now that's kind of a situation where you have to look at the theorem. If and only if we've already stated that all these, the A, B, and C added together are divisible by 3, then it stands that these two situations, let me highlight, we're talking about separate situations, before the addition and after in the parentheses, okay? I'm saying that if ABC is divisible by 3, which the theorem says it is, and then the first situation we've already shown, obviously, visually, it's divisible by 3. Then, if you look up here at my little sidebar note, well, then we could call this first situation here, let me put it in brackets. My first situation can be considered something divisible by 3. And then I'm saying the second situation here is also a something divisible by 3. Well, if you look at my sidebar note up here at the top, we have 12 divisible by 3. If that is true, then this is true. We can divide everything by 3. Okay? So what if we gave this some numeric values? Okay? So let's look at this. Let's say that this first one could be replaced by 3 times, here, let me change to back to the pink. 3 times 2. We could say that this whole thing, let's replace it with 2. Okay, just for explanation's sake. Now we can divide all that by 3. And then if we said that A, kind of like just going back to it. Let's say A is 3, B is 6, and C is 9. Each of these digits are divisible by 3. Okay, now what if we add them together? What is really happening? This becomes 6 over 3 plus 3, 6, 9 over the 3. Okay, then, well, it doesn't really become that. It's an implication more of. So then let's look at this. It's everything, it all has to be divided by 3. We're going to have to add 3, 6, 9 plus 6, okay? Well, that's 375. Let's go ahead and divide that by 3. Divide by 3. And we get a valid situation, okay? See, that was 375. And I did enter it right. 369 plus 6 is 375. Yes, perfect, okay? And that is divisible by 3. I know that's long-winded and it's going to take a second. It took me a while the first time I saw this to really wrap my head around it. Okay, and just to fully understand it, right? So let's try number 9. Number 9. What is the value of x in this expression? Okay, well, we see absolute value and a negative exponent with a variable, but it's okay. Let's go ahead and we can partially use our calculator and then also our knowledge of number theory, okay, and exponentials, okay? So what do we have? Well, let's look at the left-hand side. I see 4 over x, okay? And then on the right-hand side, well, we need to calculate and just use your calculator. Whatever is in the absolute value, and we know we're going to multiply that to x, okay? All right, so let's do that. So I have a negative second square root 169, okay? And then arrow over and minus 3, okay? Which is not minus as in subtraction, okay? Okay, notice I have those correct and enter. That's negative 16, but it's in the absolute value. So what does that really tell me? That tells me that I have 4x equal to 16x. Okay, now I can tell you what I absolutely do not like. I do not like this variable being in the denominator. So if I multiply both sides by x, what do I get? Well, what happens is I can cancel these out. This gives me a solid 4 and a solid 16 with an x squared. Now I divide both sides by that 16. Well, 16 over 16 we all know is 1. Okay? Now, what can we do quickly to pop this in the calculator to solve for x? Well, we also know, okay, and remember, this is gone, okay? We need x on its own. Well, the only way to do that, well, x squared, the inverse of that, or to undo it, we put it under the square root. So put both sides under the square root. So what does that give me? Well, I can bring x out, but now I need to pop all the rest of this in the calculator. Well, let's do that. Okay, second under the radical, give me a fraction, 4 over 16. You may already see where I'm going with this. Don't do it all in your head. Don't waste your time on a test. Put it in the calculator, push enter. Oh, enter again, push it correctly, and we have a half. And that is obviously option D, okay? Sometimes it's just easier to put it in the calculator. You can jot it down very quickly, but if you spent your time doing the extra work to say the square root of 4 over the square root of 16 and then work with it, by the time you get to that, you could already be done with the next problem. Okay? All right. Number 10. Which of the following expressions is equal to 2? Oh, we're just going to have to pop that in. Each one of those. I mean, I can see just by eyeballing, there's a couple of situations that simply do not, I can tell they're not going to be 2. Let's do it. Yes, it's going to be a process, but it's a lot quicker to put them in the calculator than it is to sit and try to do this all by hand. Okay, so let's set up a fraction. And I see 3, carried up 1, or you could have just put in 3. 3 to the first power is just 3. Doesn't matter. Let's just do it the way they have it. Okay, arrow down, 3 squared, arrow over, and I have plus 3, carried up, 1 minus 2, arrow over, because if you don't arrow over, if you haven't already figured it out, you'll just keep typing in the exponent. Okay, so now minus 3 squared. Okay, let's make sure I type that correctly. Double check it, because sometimes I don't. And push enter. Definitely not 2. Okay, and I could tell it wasn't going to be. Now let's do the next one. Let's do B. Okay, they also start with a fraction on this one. Okay, 2 squared, go down, and that's 2 carried up to 3. Arrow all the way over. It's going to take a couple taps to get that. And then we need plus and a fraction, which is 2 over 3. And make sure that you go over enough to get out of that. Now let's put in our parentheses and 2 no. Carried up, then negative 1. Now you have to arrow over and close that parentheses. Okay, now minus fraction 3 over 2. Okay, give it a second look, make sure we look good. Okay, then push enter. Oop, definitely not 2 again. Let's try C. I know it's getting redundant, but notice this is a lot faster than doing all of it by hand. Okay, 3 carried up, and that is 3 minus 2. Arrow over to get out of the exponent. Minus 2, caret, oh, no, that's not the caret up. Second time I've done that. Caret up, negative 1. Now arrow back over, and we have minus. Now we have a new fraction. Fraction of 2 squared, go down. Now we need 2 caret up to 3. Okay, I'm going to double check that this looks good. Okay, looks all right. Now let's enter. Ah, that's my 2. Okay, but just in case, try D also, and then we can really believe that C is correct. Okay, so we have a fraction. Okay, and we have 2 carried up to 3, arrow down, and that'll be 2 squared. Go over, and that's minus 3 carried up, 3 minus 2. Yes, arrow over, and that's subtract 2 carried up, negative 1. Okay, double check that we agree what we've entered. Now, there you go. That's not 2 either. So we have proven C is correct. All right, this is the last question in this video. And thank you again. You guys are the best. Thank you for watching and sharing and liking us. I wish you all happy testing.